السلام ورحمة الله.
طيب، بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين. Yes, now we will start right away the lecture. It's 8:31 even. All right. Now today we're going to start the last lecture in the course, which is in this case chapter 13. Okay, so if you notice, we just finished which chapter we just finished? 11 and now 13. What does that mean?
Chapter 12 is cancelled.
Is omitted, not required or omitted. All right, chapter 12 is omitted. For your information, we're going to start chapter 13. Chapter 13. And this chapter 13 is called Physical Properties of Solution. We just finished in chapter 11, Physical Properties of Liquids and Solid. Now we are in chapter 13, which is Physical Properties of what?
Solution.
What's the meaning of solution?
Solid, dissolved in what?
Well, it doesn't have to be solid or whatever. Solution is made, I want you to memorize all these words, is made when we have solute dissolved in solvent. I want you to memorize this word: solute, solvent, and solution. And we have the most famous example. If we dissolve in NaCl in water, this will give us NaCl aqueous. Of course, NaCl is solid. You dissolve it in water, liquid, and this will give you NaCl aqueous. I want you to keep this in mind and memorize the words. Very important: solute, solvent, and solution. Solution, which is the mixture of solute with solvent. Every word is very important, and you have to know what's the meaning. How can I tell which one is the solute and which one is the solvent? The one which is more is the solvent. The one which is more is the solvent, and the one which is less is the solute. The solute, does it have to be always solid?
No. No.
Yes. Give me example of other solution in which we don't have
acid,
solid.
Acid.
For example,
Okay.
can I have, for example, CH3COOH? What's this? CH3COOH. What's this compound? We talked about it a lot. What's this?
الخل.
Acetic acid. Acetic acid, which is al-khal. Can we dissolve this in water? It is dissolved in water, and what you have at home is actually you have CH3COOH dissolved in water, and it is aqueous. Now, what do we call the acetic acid, CH3COOH? What do you call it?
Solute.
Solute. What do we call the water?
Solvent.
Solvent. What do we call this thing? Solution. And this is liquid and liquid. Liquid and liquid. Can we have gas and liquid? Yes. when you drink any soft drink, the main solvent is water, and one of the components is CO2, which is gas. They dissolve it in water to make CO2 dissolved in water solution. Okay, aqueous. So again, in this case, the water is the solvent, CO2 is the solute, and CO2 in water or aqueous solution is. So all of these are possible. I want you to memorize solute, solvent, and solution. All of these examples are possible. You can dissolve gas in gas. Can we dissolve gas in gas?
Yes.
Yes. If you have O2 in the air, it's actually mainly O2 gas and N2 gas to make mixture air. In this case, what's the O2? Is it the solvent or the solute?
Solvent.
Why?
Because
No.
the majority
No,
is
no,
O2.
no. O2 is what?
The majority of air is O2.
Solute.
Why?
Because it's less than nitrogen in the air.
Oh, 20%. What's the nitrogen?
80.
It is the solvent because it's about 80%. And what's the air?
Solution.
Solution. Is this clear? Okay. Give me example of gas and liquid. I just give it to you right away.
Soft drinks.
CO2, NH2O. This is called carbonated water. And this is available in all the drinks, the soft drink that you're drinking. Okay. Give me example of gas and liquid. That's not important. Hydrogen and palladium. The hydrogen goes into palladium when it's solid and it becomes hydrogen. Give me example of liquid in liquid. Ethanol in water. Or I gave you which example that I gave you?
Acetic acid.
CH3COOH, which is acetic acid in water. Al-khal is available at home. Okay. Give me example of liquid and solid. Actually, it's mercury and silver, not important. Solid and liquid, everybody knows this. They have salt in water. Give me another example, very quick example.
Sugar.
What? Solid in water, on liquid.
Sugar.
What?
Sugar.
In water is example. And look here, they put liquid. They did not say only water. Anything. All right. And solid not important, but actually all the alloys. These are called alloys. Alloys, which is ايش معناها بالعربي الالويز؟
حبيبات.
ها؟ سبائك. كل السبائك تعتبر brass, which is copper and zinc, or we have carbon in gold, things like this. These are called sabaic or alloys. Okay, but we can have also the liquid doesn't have to be always water. For example, if I have I can dissolve things like CCl4 in benzene. Everybody knows what's benzene. Yes?
Yeah.
What?
Carbon.
C6H6 is benzene. All right? Can we dissolve CCl4 in benzene? Yes. And this is actually liquid in liquid. Okay, good. I hope this is clear. Now, which one we call solvent and which one we call solute?
The one that have more.
The one which is less is the what?
Solute.
And the one which is more is the,
Solvent.
and the
Solvent.
mixture is called,
Solution.
you have to memorize this name. These three is the mixture, is the solution. I hope this is also very clear. By the way, are we recording? Yes, okay. Okay. What makes things dissolve things? Why NaCl dissolve in water? Let me help you. NaCl, when it dissolves in water, what is it going to give you? Na plus and Cl minus. And the water, we know that what's the electron domain for water?
B2, E2.
You have to know this. Is it polar or non-polar?
Polar.
Polar. You have to memorize this from chapter 9. What does polar means? Partial negative and partial positive in this side. Clear? Why you think NaCl dissolve in water?
Because it will attract with the positive. Sorry.
Because the sodium plus will be attracted to water from which side?
The negative side.
Upper
The
side.
oxygen.
And the chlorine will be attracted from which side?
Hydrogen.
And this will make these small forces, these are the intermolecular forces. We call them always the forces between molecules. We call it intermolecular forces. Intermolecular forces, and it is related to solubility. It is related to solubility. Let me ask you a very simple question. Why does NaCl dissolve in water while calcium carbonate, which is also, it can go to Ca plus 2 and CO3 minus 2. This does not dissolve in water. Why?
Maybe it is non-polar.
Because its charge is huge. +2 and -2, not +1, -1.
Maybe because the intermolecular force is very great in this.
Okay, good. Yes, actually, this is one of the reasons, but you said it. So what if it's the charges are high and yeah, why doesn't it dissolve?
They stay together. Not
That's-
need to
that's
make
why
a
they
reaction.
stay together. Okay, when you actually break the bond, when you dissolve NaCl in water, you are breaking the bond between Na and Cl minus, and you are making this bond between oxygen and sodium and water and sodium. Same thing with chlorine and water and chlorine and hydrogen. All right. Why? Listen carefully now. You are breaking bond, and always breaking bond is what? Exothermic or endothermic?
Exothermic.
Breaking is always exothermic, and making is always
endothermic.
exothermic and endothermic. So now we are breaking the bond here, which is exothermic, and you're making the bonds here, which is endothermic. Same thing with here. You are breaking this bond, which is exothermic, and you're making these bonds around. Again, let me ask you one more time. Why does NaCl dissolve in water and CaCO3 does not dissolve in water?
Because the intermolecular force in CaCO3 is higher than NaCl.
Exactly. Because this total forces, this one and this one, is greater than this force which is between NaCl. See, this is not very strong bond, each one of them, but there are many bonds around. Clear? Same thing with here. There are many bonds here. The total bonds here and here is greater than the NaCl bond. What does that mean? How about CaCO3? What do you think the reason? This means what? The bond between CaCO3 is what?
Is higher than.
Is higher than or stronger than the bond between calcium and oxygen, the total bond here, and the total bonds here, which is much weaker. And that's why this dissolves and this does not dissolve. All right, that's exactly what is happening here. We call this process, I want you to know the name, solvation. Solvation means making solution. Solvation means making solution. What's the other word that we can use for solvation?
Dissolve.
Dissolve. Solvation is a process. Solvation is a process, and we can say we can make or NaCl can be or the process we can make solvation for NaCl in water. We can make solvation or we can dissolve NaCl in water. Okay. As I said, why things dissolve? Because solute interaction and solute solvent interaction and solute solvent interaction. The main reason is actually the interaction between the ions and the dipole, or the dipole with the induced dipole, or the ion with induced dipole is example like this. All right, what do I mean by this? NaCl dissolve in water, as I just explained to you. Na has a plus charge, and water have it's polar, so there is negative charge, and so these are making the bond, and that's why it dissolves. Okay. Helium or CO2 dissolve in water. CO2 is Ab2E0, the electron domain. Is it polar or non-polar?
Non-polar.
Non-polar. If it's non-polar, this means it has no charges. How come it dissolves in water? Because of the induced polarity. What does induced polarity? You remember the London forces? London forces.
Yes.
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 Yes, this is London forces, the intermolecular forces that are, we call it also induced polarity, and they are attracted to each other by the induced polarity. Same thing with Fe, which is iron 2 plus, and if we put air in it, oxygen, is it polar or non-polar? O2, is it polar or non-polar? Definitely non-polar.
Non-polar.
Definitely non-polar. Why does it dissolve or bind with iron? Because it makes the induced dipole. And it dissolves in water and iron like this. As I told you just a while ago, what are we doing? I want you to look carefully at this process. Okay, what are we doing when we dissolve? Imagine that this solute is sugar, and this one, the solvent, is water. Okay, and this is the solution, this is the solution, which is what? Sugar and water. What are we doing in order to go from sugar? I mean, if we have solid sugar, this is solid, and this is liquid, and we're making solution, which is this one, solution. What are we doing? We are first breaking the bond and the solid. So we're making the solid into bonds like this. Is this exothermic or endothermic process?
Exothermic.
What?
Exothermic.
Breaking and making. Always keep this in mind. Breaking bonds is what?
Exo.
And making bonds. Which one is exothermic? Which one is endothermic?
Breaking is exothermic.
Breaking is endo. Breaking is endothermic, yes. I think breaking is endothermic, and making is Did they make a mistake in the first slide?
Yes.
I
You said
think-
breaking is exothermic.
Yes, I think I made a mistake. Yes. Breaking is endo, no. Oh, I said, oh, no. That's, by the way, this is wrong. Oh, my God. Yes. Breaking is always endo, and making is exo. I made a mistake, yes, I remember that. Okay, so yes, when you break a bond, it's always endothermic. When you make a bond, it's always exothermic. So when you break the bonds of the sugar, is this exothermic or endothermic?
Endothermic.
Endo. So going from here to here is endo. Delta H, is it positive or negative?
Positive.
Why? Because endo means
Endo mean
delta H means greater than 0. So this must be greater than 0. Now, when we went from here to here, what did we do? We break the bond between what?
breaking bond.
Between
Endothermic.
between the water molecule. We said, let's assume that this is water. So we are breaking the bond between the water molecule. Is this endothermic or exothermic?
Also endothermic.
Also endothermic. What's delta H? Greater than 0. That's this one and this one. When we make the bonds between sugar and water, is this exothermic or endothermic?
Exothermic.
This is exothermic to make the bond. So delta H3 is exothermic. Okay, and this will be less than 0. Now, if delta H solution, is equal to delta H1 plus delta H2 plus delta H3. So when you make the solution, you are breaking, and making. Delta H1 will be always what? Positive. Delta H2 will be always positive, and delta H3 will be always negative. So when delta H solution is less than zero, this means the total here is less than zero. Is this going to be soluble or not?
No.
What? You're not following. What's wrong? يا شباب لحظة شوية. We call this one delta H1. Are you following? Hello?
Yes.
And delta H1 is always what? Positive or negative?
Positive, because
always positive. Delta H2, when we break the water molecules, and is this going to be positive or negative? Always positive. Okay. Delta H3 is making the bonds between the water and the sugar in this case. Is it going to be positive or negative?
So be negative.
Totally negative. Good. Now, always this is the case. Now, keep this in mind. Now, when are we going to have delta H solution less than zero? When are we going to have it less than zero?
Delta H3 smaller than the 2.
When delta H3 is greater than what?
Delta H1, delta H2.
Exactly. So we're going to have it less than delta H1 if delta H3 is greater than, of course, greater in value. It's negative, but the value, let's assume delta H3 is minus 100, and delta H1 is minus 20, and delta H2 is minus 30. I've lost 30, of course. So when is delta H3 is going to be negative? When delta H3 in value is greater than delta H1 plus delta H2. When is it going to be greater than zero? Delta H solution is greater than zero. When delta H1 plus delta H2 is what?
Greater
than value than
3.
Delta H3. Okay. If we have the first case, if it's less than zero, then definitely there will be solution and it will dissolve. All right. But if we have delta H1 and delta H2 greater than delta H3, then maybe it will dissolve. Or maybe it will not dissolve. I repeat one more time. The delta H solution is the addition of delta H1 plus delta H2 plus delta H3, and always this will be going to be positive, and this will be negative. If the total value is negative and it's less than zero, then definitely it will dissolve in water, definitely. But if delta H1 and delta H2 is greater than delta H3, then it will be positive, the total will be positive, and maybe it will dissolve, maybe it will not dissolve. There is another reason, I will talk about it in a while. So if delta H solution is less than zero, it will be exothermic, and Is this going to be 100% dissolved or not dissolved?
Dissolve.
Dissolve.
Definitely it will dissolve 100%. Okay, but this one
Will not dissolve. Maybe and maybe not.
maybe it will not. Maybe it will dissolve. Maybe it will not dissolve. Is this clear? Because there is another reason. I will talk about it in a short time. Okay. Now, another thing to talk about, which is concept I want you to know very well. There is a concept called like, dissolve, like. Okay, I want you to read this sentence. Like, dissolve, like. Like, dissolve, like. All right, what do I mean by this? This means ionic compound or polar compound dissolve in polar solvent. Okay, ionic or polar dissolve in polar solvent. Non-ionic, non-polar dissolve where? In non-polar. Is this clear? What's this concept called?
Like,
Like
dissolve.
Like, dissolve, like. Tell me why I give you this example. Example 1 and example 2. In example 1, why like, dissolve, like in this case? Because polar or ionic means charge, dissolve in what?
In polar.
Polar, what does polar means? It has what?
Charge.
Partial what? Positive or partial negative. Is this
Yes.
clear?
Yes.
And in concept 2, why like, dissolve, like? Because it's what?
Because both are non-polar.
Non-polar. Good. Let's solve this example. Which one of these four will dissolve in water, H2O, and or in benzene, C6H6? Of course, water, we know that it is what?
Polar.
Polar. But benzene is
Non-polar.
non-polar. Very good. You have to keep this in mind because there is no difference. We said that the bond between C and H is always non-polar. Okay, let's look at this example. Bromine. Where does it dissolve? In water or in benzene?
In
Benzene. Because it's
Why?
non-polar.
Why?
Non-polar.
Non-polar.
So because it is non-polar. Very good. How about sodium iodide? Where does it dissolve? In water or in benzene?
In water.
In water.
Definitely Na plus Cl minus
iron.
will dissolve in water. Ion dipole interaction. Okay, how about CCl4? CCl4 is like this.
Non-polar.
What's the electron domain?
AB4 E0.
Which is non-polar. Where does it dissolve? In water or in benzene?
Benzene.
Benzene.
It will dissolve in benzene. Okay, how about CH2O, which is COH. Is there any polarity in here?
It's polar.
It's polar.
It is polar like this. Where does it dissolve? In water or in benzene?
In water.
Why? Because like
Because
dissolve
it's
like.
polar.
Polar with
Yes.
polar. Is this clear?
Yes.
Very good. All right. Now, let's take NH4, NO3. NH4, NO3 dissolve in water, and it will give you NH4 plus NO3 minus aqueous, and it dissolves in water. But if you calculate delta H solution, delta H solution equal to what? Delta H1 plus delta H2 plus delta H3, we will find that it is positive. Remember what's delta H1, delta H2, delta H3? What's
Yes,
delta
yes.
H1?
Breaking the the pound
The solute.
in solute, yes.
Delta H2.
Breaking pound in solvent.
And what's delta H3?
Making bond between solute and solvent.
Solvent. Solute
Yes.
and solvent. And delta H1 is always what?
As positive.
And delta H2?
Also positive.
And delta H3?
Negative.
Always negative. We find delta H solution is positive. What does that mean? The total process is what?
Is greater than 0.
This means it is endothermic.
Yes, endothermic.
If it's endothermic, maybe it will dissolve, maybe it will not dissolve. From the heat point of view, it should not dissolve, right? But there is a reason. There is another reason which is called entropy. I want you to memorize this word, entropy. Entropy. Another reason that make this thing, even though it is endothermic, but it will dissolve because of entropy. I want you to memorize the word entropy. What does entropy? ايش معنى entropy بالعربي تعرفونها يا شباب؟
الفوضى.
الفوضى. Yes. الفوضى or العشوائية. Maybe I think is better than الفوضى. Is the, if we want to give Arabic name for it, it should be العشوائية. All right, that's the meaning of entropy. Entropy. This entropy make the thing dissolve because of entropy. Okay. Okay. What does entropy means? Entropy is this example. All right. Like if you take these two boxes and you have them together like this. What's the color of the balls in this box? What's the color?
Yellow.
Yellow. What's the color of this box? Balls.
Violet.
Okay. When you take this separation out, what will happen? Remove barrier. Remove the barrier. This is the barrier. And we remove the barrier. What will happen? Are you going to see? Are you going to see only the yellow? This yellow, I will write them as yellow. I'll call them yellow, 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 and on this side, purple, 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 purple. Is this possible? You're going to see without barrier here. Are you going to see the purple here only and the yellow here only?
No.
No, never. Impossible. Why? They will mix together like this. Now here we have more entropy. More. This is the meaning of entropy. The entropy is also an energy. Entropy is energy. And make the solution which is positive, like this solution, positive, which is delta H is endothermic, is still dissolved in water because, or dissolved in solution because of entropy. Also, this example here, This is not sugar in water, but this is something else. Okay, here, what's delta H in this case? Delta H3 is smaller than delta H1. This is delta H1 and this is delta H2. Delta H3 is less than delta H1 plus delta H2. So as this process is in delta H solution is greater than 0, this means is this endothermic or exothermic? Endothermic. It is endothermic, but it dissolves. Why does it dissolve in liquid here? Because of the entropy. I hope this is clear. So this is called entropy, and the entropy means العشوائية, and that's entropy. طيب, how can we go from here to here? كيف نعكس الانتروبي؟ What's the reverse of entropy? فوضى أو عشوائية. It needs intelligence. What does intelligence mean? Okay, فايش عكس العشوائية؟ From here to here, entropy, and from here to here is intelligence. What does intelligence means?
ذكاء.
ذكاء. إذا إيش what's the reverse of entropy?
Intelligence.
ذكاء. You have, in order to put this back into this system, you need to be clever enough to differentiate between the colors and take this one, put it here, and take this one and put it here. Is this clear? That is the meaning of entropy. I hope this is clear. All right. Next. Next, we're going to talk about concentration. What's the meaning of concentration?
تركيز.
تركيز. What's the reverse of concentration? We took this in chapter 4.
Dilution.
What?
Dilution.
Dilution.
تخفيف.
تخفيف. Dilution. Dilution. All right. تركيز is concentration, and this is dilution. Concentration means more and more, and dilution means less and less. All right. We talked about this molarity. We discussed it before, right? What's molarity?
Mole in
Moles of solute.
Number of moles.
and volume. Over
moles of what?
Of solute.
Of solute. Divide by what?
The volume of solution.
Number of liters or volume. Volume. Let's put not number but volume. Volume. And even this one. I'll use only moles. Moles in solute. Divide by volume in what?
In solution.
In solution. The solution. You have to be careful here. Solution. And what the unit must be here?
And
Liter. This is the unit is moles, and the unit here is liter. And so the molarity we represented by a big letter which is called M.
yes.
M. And what's the unit for M?
Mole over liter.
Moles over liter. Is this clear? This calculate the concentration of the solution. How much is the solution? That is called molarity and represented by M like this. There is another unit for concentration. It's called small m, and it's called what? You know it. Molarity. What's the difference between this one and this one?
It is over the gram. I mean the mass, not
This
the
is
volume.
called molarity. This one is called molality. And what is molality? It's, you have to memorize this now. Moles of solute
over
exactly
mass.
the one at the top. Which is, what's the unit?
Is moles.
Moles. Okay. Divided by kilogram
Yes.
of solvent.
Not solution.
Not solution, but solvent. And the unit is kilogram. So what's the final unit for molality, small m?
Mole over kilogram.
Moles per kilogram of solvent. You have to memorize this. Okay? Okay. Next, there is another thing which is called mass percent. You have to read it like this. Mass percent. Mass percent. And this is the mass of solute divided by what?
Mass of solution.
Mass, total mass. Total mass
Of solution.
of solution
Divided by 100.
times
Times 100.
100. Okay. And what's the unit?
Percent.
Unitless. No unit.
Only person.
No unit. Is this clear?
Yes.
Good. And last is actually mole fraction. Mole fraction, we represent it by capital X, like this. And this is called mole fraction, which is moles of solute divided by moles of solute plus what?
Moles
Mole
of solvent.
of solvent. That's it. And what's the unit again?
Unitless.
Unitless. Unitless also. And this small fraction of solute. Can you give me what's the mole fraction? Or I write it here because it's good. Let's go write it up there. Okay. What's the mole fraction of solvent? I'll call this mole fraction of solvent. What does it equal to?
Moles of solute. Moles of
solvent. Moles of solvent divide by what? Moles of solute plus moles of solvent. All right, and what's this called? Mole fraction of solute. That's why this X I'll write here, solute. Let me ask you very, very simple question. The X, this X and this X, what will be the value of this X and this X?
Less than 1.
It must be less than what?
1.
Less than 1. Must be less than 1. I want to ask another question. What's X solute plus X solvent?
Equal 1.
What?
1.
Exactly. You have to keep this also in mind. I want you to look at these and memorize them very, very well. What's molarity?
Moles.
Moles of what?
Of volume of solution.
Moles of what?
Solute.
Solute. And divide by volume of solution. What's molality?
Moles of solutes divided by mass in kilogram of solvent.
Of solvent. What's mass percent?
Mass of solute divided by total mass of solution times 100.
And what's the meaning of mole fraction? We have to say mole fraction of solute first.
Yes. Moles of solute divided by moles of solution.
No, not moles of solution. Moles of solute plus moles of solvent, because each one is different and we calculate it differently. It's moles of solute plus moles of solvent, which is not moles of solution.
Okay.
Okay, good. And what's mole fraction of solvent? I wrote it here, which is the same. You have to know these things, and you have to know how to calculate them. You have to know how to convert from one to the other also. Is this clear? Good. We did this all. Let's solve this problem. A solution made of dissolving 170 grams of glucose in enough water to make 1 liter solution. Can you calculate the molarity first? Let me help you. The molar mass of glucose is 180.2. So this is the molar mass of C6H12O6. So how can you calculate the number of moles?
Divided 170 over
Exactly.
180.
All right. What's the answer?
0.944.
Very good. And in order to calculate molarity, this is the unit is moles here. Why should we divide by what?
Volume of solution.
Volume solution. What is it according to the question?
1 liter.
Yes. What's a liter means?
1.
So what's the answer? Very quickly.
0.4844.
944.
Okay. Very good. Now, can you calculate the molality? Molality.
Yes.
How? We already calculated the number of moles.
We changed the volume to kilogram, I mean.
Okay, go ahead. You're given the density here. Density equal to 1.062 gram per milliliter. And the volume is what?
In liter.
1 liter. What can you calculate? The mass.
The mass, yes.
Okay, go ahead, calculate the mass. What's the mass?
It is 1062 grams.
Gram. Or, yeah, let's keep it a gram. Okay, can you calculate the molality?
Yes.
Yes.
How?
moles of solvent of solid over kilogram of
What's the first thing you must do?
Change the gram.
Subtract
You
by
have to subtract what?
170.
Why?
Because we want the solvent, I mean,
Exactly.
not all the
This is the mass
solution.
of the solute, and this is the mass of the solution. I want the mass of the solvent. Okay, subtract them very quickly.
That will be 892.
892 gram. And
Yes,
what do they do next?
change it to kilogram divided
Yes.
by 1000.
Kilogram. Now, what's the molality? You divide what?
The number of mole of solute.
Calculated here. Number of moles
Yes.
here. Divide by what?
By
Kilogram of solvent.
Kilogram. And what's the answer? Quickly.
1.06.
And look at the unit here. What did I put? Small m. What should I put in this?
Moles per kilogram.
Big
Moles
M.
per liter.
Mole here. I put big M means moles per liter, while here small m means moles per kilogram. Is this clear? Okay, very good. Now, let me, before we go to this, okay, let me also give you another thing. What is mass percent, by the way? Mass percent. What does equal to what?
mass of solid
Mass solute
over total mass.
over total mass
Multiply by 100.
multiply by 10 to the power 2. Right?
Yes.
Yes, 10 to the power 2 is 100. Exactly. Is this clear? I want to define two things for you. ppm and ppb. ppb. ppm, that's called part
per million.
Per million. And ppp, it's called part
Per billion.
per billion. Is this clear? This
Yes.
part per million is exactly mass solute divided by total mass times 10 to the power 6. Okay, now I want you to define part per billion. What are you going to say? Yes? Mass
Solute divided by total mass.
divided by total mass times
10 to the power 9.
9, exactly. 9. Okay. How about if I have PPT?
To the power 3, it will be.
10 to the power what?
I think 3.
10 to the power 12 parts per trillion.
T represents what?
Trillion.
Trillion. Okay.
Million, billion, trillion. million, billion, and trillion.
What about thousand?
Oh, we don't have thousand. We don't have thousand. No, we don't. It's actually PPT. These are all now use these units in environment. Rubbing alcohol, a mixture of C3H7O8 and water, that is 70% isopropyl alcohol by mass. Okay, so what's given to you here? Mass percent is equal to what? 70%. 70%. Oh, okay. Can you change this mass percent into molarity and molality? Can you do that?
Maybe.
How? You have to assume mass of solution
Is 100? 1 gram?
is 100.
100.
Assume. If it's
Yeah.
100, then what's the mass of solute?
It will be 70.
Is 70. And what's the mass of water?
30.
What?
30.
Exactly. Now, if you know these facts, can you calculate molarity?
Easily, yes.
How?
We
By the way,
change
the
the
mass of the rubbing alcohol,
mass of solute
this is the
to
molar
moles.
mass of rubbing alcohol, 60.09. And we have 70 gram, so can we calculate the number of moles?
Yes, yes. We will do 70 divided by 60.
The easiest actually is to memorize the molality. Can we do the number of moles is what? 70 gram divided by 60.
1.16.
What?
This is the mole of solute.
Yeah, what? 1.16
Yes.
moles alcohol. Okay, divide by how to calculate molality.
Divided by 0.03.
Exactly, 0.03. Why is that?
Because we will change it to kilogram.
Exactly, 0.03. What's the answer?
$38.7.
39 molal. Very good. Do you know how to do it? All right. Now, can we calculate molarity? M. We have the number of moles. It's already 1.16. But I need to know the liter solution. I have the density here. And what's the mass of the solution?
It is 100.
Yes, we assume it's 100.
Yes.
And so can you calculate the volume?
Yes.
Okay, go ahead quickly. What are you going to do? Divide 100 divide by what? 0.79. Okay, what's the answer? Yes.
0.13, I think.
Not B. It should be more than 100. Oh, in liter. Then it should be more than 100 actually. It will be 1 point what? Divide 100. Divide by 100. Divide by 0.79. And this will give you the mass in liter. What's 100.79?
126.
126?
0.6.
126.6. Okay. Now change it to liter. This is milliliter. What is it going to be?
0.126.
According to your calculation. And what's the answer in this case?
$9.16.
Exactly. Do you know how to convert now from molarity to molality to mass percent or whatever? Is this easy?
Yes.
Now, what's the effect of temperature in solubility? What's the effect of temperature in solubility? What's the meaning of solubility? Dissolving. Solubility الذائبية. وأحسن كلمة بالعربي الذائبية. Yes. Agree. الذائبية means dissolving. What's the effect of temperature? هل if you increase the temperature احنا نعرف لما تذوب السكر في المي كل ما زدت الحرارة what will happen to the sugar? You will dissolve more and more, right?
Yes.
Yes. That's the case for glucose. Is this the case for everything? شوف كل ما زدنا الحرارة كل ما ارتفع كمية الذوبان. This is the temperature and this is the amount dissolved, solubility. As you increase the temperature for glucose, definitely the amount dissolves more and more and more. How about this one? What's the effect of temperature? How about this one? Also, if you increase temperature, solubility will increase. How about this one? Yes. How about this one? Yes. How about this one? Yes. Yes. But look at this one.
It decrease.
Does it decrease or almost?
The last one, I mean.
The same.
No. But this one is the same almost. الملح ما تأثر عليه الحرارة. الملح يذوب بنفس الكمية سواء كان more or less. And look at the last one. What happened? What's the effect of temperature?
It decrease.
Decrease solubility. Decrease solubility. So the temperature not always help the solubility. Actually, maybe it will dissolve, to make less. When you dissolve gas in water, انت لو اخذت علبة قارورة كربونيتد ووتر، اني كربونيتد ووتر، اول ما تفتحها وتذوقها كيف طعمها؟ حادة كذا صح؟ because there is CO2 in the water. Okay. لو خليت علبة الكربونيتد ووتر هذه اللي هي بيبسي او كولا او وات ايفر او 7 اب، خليتها في الشمس لفترة طويلة، ايش حيصير؟ لو ذقت طعمها كيف حيكون؟ حتكون فقط ماء وسكر صح؟
Yes.
يس. ليش؟ لأن CO2 طلع من القارورة. التمبريتشر what's the effect of temperature on solubility of gas in water? Always what?
Increase.
Decrease, reduce or decrease. The solubility decrease for gases. يعني الآن أي واحد at if we have gases, anything in gases, how are you going to draw the curve for gas, for CO2 in water?
Like the last one from that
Yes,
bottom.
it will be like this. Definitely it will be like this. Not similar to the last one, even more sharp. It will be very sharp, like this. Is this clear? On the other hand, the effect of pressure is the reverse. The effect of pressure is reversed. If you increase the pressure, the amount of the gas will go more down, like this. Is this clear? This is less pressure. pressure يمثل الغاز اللي فوق. This is more pressure higher, and this one pressure is lower. Which one is dissolving more, at higher pressure or lower pressure?
At higher pressure.
Higher pressure dissolve more. Okay, the law that we use for the, of course, you notice this. أنت لما تشتري carbonated water or Pepsi or whatever, when you open it, what will happen right away when you open it? The gas will come out. Why is that? Because it was under pressure when they close it. When you open it, right away the pressure will be less and the gas will come out of solution. Is this clear? This is, we know the concentration or the amount of gas in liquid is related to pressure. The amount is related to pressure, and C is directly proportional to P. This means as you increase the concentration, the pressure will increase, or C equal to K times P. What is C? Concentration. In what unit? Big M. What's big M? What's the unit for big M?
Molarity.
Molarity, which is what? What's the unit?
Over liter.
Moles per liter.
Liter.
Okay. And what's P?
Pressure.
Pressure. What's the unit for pressure?
Pascal.
What?
Pascal.
Atmosphere or Pascal, but we're going to use atmosphere more. And what will be the unit for K then?
Constant.
Yes, what's the unit for this constant?
Moles per liter
Mole
times atmosphere.
Divided by liter times atmosphere. So that atmosphere will go with atmosphere, and the unit will be left, which is moles per liter. And this is known as Henry's law. I want you to memorize the name Henry's law, and this is called Henry's constant. Henry's constant. And what's Henry's law does? Solubility of what in what?
Gas and solid. And
gas
liquid.
Liquid. In water or anything else. This is known as Henry's law. Henry's law. All right? Very good. I will stop here because the time is over, but we'll come to the to this problem next time, inshallah. All right? And as usual, let me stop here.